Okay, so in class on Thursday, we left off talking about Doritos and ice cream, right? Ice cream, pizza, pizza. All right, Doritos was later in the day, so let's just. I'm going to go back to the table that we had. So it was pizza and ice cream, pizza and ice cream, and does anybody remember the numbers that I had down? We made 0 pizza and how many ice cream? 8 ice cream. We made 0 ice cream and how many pizza? What was it? 4? And then what was my combination? 4 pizza, 2 pizza, and 4 ice cream. And then we took that info and we drew a graph, right? Looks something like this. And I'm just going to put pizza here, and this is going to be ice cream here. And we've got our production possibility curve, looks something like that. And we know that we can produce 4 pizza and 0 ice cream, or 8 ice cream and 0 pizza. Okay? So that's our production possibility graph. Now we ended, I believe, with increasing our production possibility curve, right? And we call this line X. Is that where we left off? Yeah? So I'm going to put line X equals, and we said that equals growth. And growth happens when we have an increase in land, labor, and capital. I'm going to write this small so we can fit it. Land, labor, capital. That's how we get growth. We have more resources. Okay? And then what we didn't put down last time is that we also could have, let's call it line Y, and that equals a decrease in, we'll call it productive capability. And really that just means that we've lost resources, okay? And if I was going to draw a line Y on my graph, it's going to be a shift inward or to the left. Something like that, and we'll call that line Y. Okay? So it's important for us to know that our production possibility curve can change as resources change. Okay? Now, one thing we didn't get to on Thursday is that we can also use our production possibility curve to show costs. Okay? So let's just add here, I'll add the question. What's the cost of changing production? Say, what is the cost of changing production from, we'll say, point A to point D? What's the cost of changing production from point A to point D? So let's go back to our graph, and I'm going to put point A on my graph. And we said that point A was, oh shoot, wrong curve. Get rid of that. Let's say that point A was about right here. Okay? And we said that our numbers at point A were 2 pizzas and 4 ice cream. 2 pizzas, 4 ice cream. And let's say that point D is way up here where we are making 4 pizzas and 0 ice cream. So we'll call this point D. Let's see if I can squeeze it in here. So we want to know then, what's the cost of changing our production? If in our economy we decide, you know what, yesterday we produced at point A, but today we want to produce at point D. Okay? Whenever we move along our curve like we are here, we can gain more of one good, but that means that we have to give up something from the other good. Does that make sense? We can't have more of both. So there's always going to be a cost when we move along our production possibility curve. So if I move from point A to point D, the cost is I'm going to lose or give up 4 ice cream. Let's just jot that down, and we'll make sure we all understand. So the cost is 4, and I'm going to abbreviate ice cream. So it's important that you remember when we talk about costs, okay? Costs are always things that we give up. So when I'm asked this question about what's the cost of changing production from A to D, first thing that has to come into my mind is, all right, I got to figure out what I can't do anymore, what I'm losing because we're changing this. Well, I know that when I go from A to D, I'm gaining pizza, which means I must be giving up ice cream then. Does that make sense? I just got to use my graph to figure out what exactly I'm giving up, and that's how I get 4 ice cream. Questions on that at all? That's pretty common. You'll see that when you do some of the practice production possibility graph questions tonight. You'll see some questions like that. Those are pretty common for the AP exam as well. You'll be given a production possibility graph, and you just have to show that you understand what the information on that graph is talking about. Okay? All good? All right. Last thing with production possibility graphs is, and I am going to fast forward to a new sheet here, is we're going to put down constant versus increasing costs. Constant versus increasing costs. So we know how to calculate costs, okay, when production changes, but now we have to understand that how our production possibility curve is shaped, okay, distinguishes what types of costs are going to be happening in our example. So we're going to draw 2 side-by-side graphs, okay, both production possibility graphs. They're just going to look a little bit different. So we'll put an A here, and below that I'm going to draw production possibility graph that looks like this. It's going to have a straight line. Okay? And over here, I'm going to put a B. We do the same thing. But this production possibility graph is going to be curved. A curved line. That. Okay? So both of these graphs represent a production possibility graph. I think that's important for us to know. Okay? The only difference between the 2 graphs are the costs that are going to be illustrated. So let's go back to A. Okay? And let's say in A, the 2 goods that we are going to be producing are pizza. So I'm going to write pizza up here. And strombolis. What? Stromboli? You guys know what a stromboli is? It's like a pizza folded in half, right? Kind of. So anyway, I chose pizza and stromboli for a reason, okay? Because graph A represents what we're going to call constant costs, okay? So let's put here, we'll put it underneath because I don't have a ton of room. We'll put constant costs. Whenever you see production possibility graph, that's a straight line, okay? That production possibility graph represents constant costs. Everything else about it is the same, okay? Still all the ways that an economy can use its resources, but the costs are going to be constant, okay? And let's just add to this, okay? We're going to say constant costs, and we're going to say as production changes, resources are perfectly adaptable. So costs remain constant. Now, what it means for resources to be perfectly adaptable is that, if you look at pizza and strombolis, the resources needed to make both of those goods are virtually the same thing, right? Whatever you're using to make pizza, you can use to make strombolis and vice versa. So when we talk about giving up pizza and taking those resources to make strombolis, we can use all of those resources. There won't be anything that's left out, okay? And so if I was going to go back to my graph, and let's say that on my graph I was going to make, let's say I could make 10 strombolis and 0 pizza. Okay, that would be my first point. And then let's say that I wanted to add, let's say I'm going to make 2 pizzas. Okay? Well, if I look here, let's call that 8 strombolis now. So when I gained 2 pizzas, sorry, my 2 is a little bit sloppy. But when I gained 2 pizzas, I gave up 2 strombolis. If we're going to be experiencing constant costs, if I'm going to gain 2 more pizzas, now I'm going to make 4 pizzas. How many strombolis can I now make? 6, right? And so that's what you would find. That ratio between what you're gaining and what you're giving up will always be constant when you have a production possibility curve that is a straight line. We call that constant costs. Okay? Now, we put up here a ratio of 2 to 2, right? Every time we gain 2 pizzas, we give up 2 strombolis. But it doesn't have to be 2 to 2. It doesn't have to be 1 to 1. It could be 1 to 2. So if we gain 1 pizza, maybe we give up 2 strombolis. But then if we gain 1 more pizza, we're going to give up 2 more strombolis. Does that make sense? So it doesn't have to always be an equal ratio. It just has to be a constant ratio. Okay? And so that will always happen when we have a production possibility curve that is a straight line. Okay? Now let's go to our second graph here. The second graph illustrates what we call increasing costs. We'll jot that down underneath. Put increasing costs. And now the resources are not going to be perfectly adaptable. So we can't use pizza and strombolis for an example. Okay? We'll use, let's say, pizza and computers. So now we know that our resources are not perfectly adaptable, okay? And so when we want more pizza, we're going to have to give up an increasing amount of computers and vice versa. So let's just put down here that as production changes, and resources are not perfectly adaptable, Say and resources are not perfectly adaptable the costs increase. So if we were going to go back to our graph, let's say that we can make 10 computers and 0 pizza. Let's say that we want to add a pizza. We make 1 pizza. You can see that we probably don't even give up a full computer. Okay, I can't even fit a number in there. And then if we want to add another, we'll say we're going to add a second pizza. The difference between the first cost and the second cost should be greater. So maybe we gave up, half a pizza, or I'm sorry, half a computer the first time. Now we made the second pizza. Now we're going to give up maybe, 2 computers. And if we add a third, we're going to give up even more. So the idea here is that the amount of computers that we're giving up to gain pizza is going to continue to increase. The cost or the ratio will not be a constant cost or ratio. Okay, it will increase. And that's because the resources are not perfectly interchangeable. Okay? When we want pizza, we can't use, all of the computer resources to go and make pizza. That would be interesting. And vice versa. When we want computers, we can't use all of the pizza resources to make computers. So we have to give up more and more of the other good. Okay? So that's going to be an important concept for us to know about the way that the production possibility graph is drawn. Okay? All right. So everybody got that down? I'm going to X out of that. And